In this video, we'll be taking a look at how we can bootstrap our data science projects in terms of organizing code, data, as well as other files that we need. For this tech stack, we'll be taking a look at Python 3, which will be managed by Anaconda, as well as Jupyter notebooks for our experiments, and various Python libraries that you might need in a certain project. First off, we have to install Anaconda. Installing Anaconda is pretty straightforward. All you have to do is to go to Anaconda's website. Under the distribution page, you'll find their download links for the different platforms of your choice. In my case, I'll be using Linux, wherein the installation file comes in the form of a shell script which we can execute using bash, followed by the name of the shell script. Once the installation is done, it usually places the Anaconda installation in your home directory. You can activate it by issuing the command source ~/.bashrc. Now, Anaconda is a way wherein you can manage different Python environments in isolation, meaning you can have an environment that uses Python 2 and a separate environment that uses Python 3, together with its own respective libraries with different versions for each environment. In our case, we'll be creating an environment called devlogs by issuing the command conda create name devlogs and using Python 3 as our main Python installation. So as you can see, I have my terminal here, which is currently set to base, the default environment for Anaconda, and I can create the environment by saying conda create name devlogs, and I'll be using Python 3. Once that's done, you can activate your environment by issuing the command conda activate followed by the name of your environment, in my case devlogs. As you can see, the base indicator here changed to the environment devlogs. Now we can install some libraries, although there are some default libraries already included with Anaconda. But just in case, for this video, we'll be taking a look at Jupyter, Pandas, Setup Tools, and Pathlight. So you can install a library within a certain environment, so you have to make sure that you're in the current environment that you just created by issuing the command conda install followed by the name of the environment, or rather the library that you'd like to install. In my case, it would be first up Jupyter. Okay, I also need pandas. As well as setup tools and pathlight. Okay, so once you have those libraries installed, the following is the proposed directory structure of a data science project. So assuming we have a project called my project, which will serve as the root directory of your project. Within the root directory, you might have 3 or 4 directories depending on what you need. First off is the src directory, where we would dump all our Python code. The second directory is a notebooks directory, where we would store our Jupyter notebooks. And the third directory is a data directory, where we would store our data files, usually in the form of CSV files. You might also want to have a models directory, where you would save your TensorFlow or Keras models that you just created. Also directly under the project directory will be 3 files, an environment.yml file, a gitignore file, and a readme.md file. We'll be going through these files later on, but basically the readme.md is your introduction to this project, so you can write in instructions on how to replicate this project for other developers or data scientists to use. Environment.yml file will be a setup file, so other data scientists will be able to replicate your Anaconda environment by issuing a simple Anaconda command. And gitignore will of course allow you to ignore certain files in your project if you are to commit your project to a certain repository. So we'll first take a look at the src directory, specifically a setup.py file, which uses the setup tools package. This allows you to optionally bundle your Python code if you wish to redistribute it as a separate package. Right, so I'll create first a directory called my project. I'll create the needed directories under that project root, namely src, data, as well as src data as well as notebooks. Okay. We'll be generating environment.yml file later on, but for now let's go to src and put our setup.py file right there. So the contents for the setup.py file will be the following. Actually, just copy it here. Give the name of your project. Okay. Once we have that set, the next thing that we can set up is a config.py file, which is found inside a directory of the same project name inside the source directory. So you can think of this as your namespace where you would dump all your Python files in, allowing you to have an organized way of importing it later on in your Jupyter notebooks. So under src, I'll create another folder called my project, and within that I'll have a file called config.py. So this one makes use of the pathlib directory to refer to various directories within your project, such as data. So for example, I might have a variable here called data dir raw, which will be part of, which we'll call the path class, and create a reference to the data directory. Now if you notice, you can also include other Python libraries here as well, such as pandas. And the idea here is that your config.py file will contain global variables that you might use throughout different Jupyter notebooks. This avoids redundancy in having to refer to things such as data frames from certain data files, or other global variable parameters that you might want to use in your experiments, such as alpha, sigma values, as well as other default values. So let's say that in my data directory, I have a sample CSV file, let's say, which contains x1, x2, x3, y, and a bunch of values here. Okay, which we'd like to refer to in our config.py file. So we say data sample is equal to pd. Using pandas, we can read that CSV file, pass in our data dir raw variable, and refer to that file name sample.csv. Okay. So data sample here becomes a global variable that you can use in your Jupyter notebooks. So let's say you have two Jupyter notebooks that uses the same sample.csv file. We can instead load data sample instead of having to call these routines again. So going back to the directory structure, we'll now move to the notebooks directory where we would store our Jupyter notebooks. Okay, but before that, I forgot something. Okay. Together in your my project directory within source, or whatever the name of your project is, we also have to include a init file, so that when Python reads this directory, it will be able to refer to the other Python directories as part of its path. Okay, now let's move to the notebooks directory. So this is where we would have our Jupyter notebooks. So I will fire off another terminal, go to the notebooks directory, and start the Jupyter notebook server by saying Jupyter notebook. And let's create a new notebook here using Python 3. Okay, So let's say I'll name this notebook experiment 1. Usually in the top part of your notebook, this is where you would refer to the variables that you've just put in our config.py file, namely data sample. So to do that, we say from config, or rather our namespace rather, myproject.config, we import data sample. Okay. Save this. Oh, sorry. Before that, as you can see, it doesn't read, it won't be able to detect myproject.config. So we have to do something a little bit more. Okay, so we have to first import sys and append the src folder to be part of our path. So in our Jupyter notebook, we first say import sys.path.append src. Okay. Since src is located one directory above our notebooks directory where our Jupyter notebooks will be stored in, we have to refer it this way. Now let's try to run it again. You can see there's no more errors can be found in our Jupyter notebook. So let's see if data sample works by examining it and saying data sample.head. Okay, so as you can see, data sample, our global variable found in our config.py file, is read appropriately as a data frame. Okay, so aside from the config file being a separate file where we can store global variables, we can apply the same concept in other Python routines as well. So for example, let's say that we have a Python file called utils.py, okay, in the same directory of my project. And let's say we have a function there called greeter, which accepts a single variable and simply prints out the contents of that variable, or the argument that you pass to greeter. If we were to refer this method in our Jupyter notebook, using the same technique, we would say from my project, our namespace, dot the name of the Python file, in this case utils, without the .py extension, and import the name of the function, let's say greeter. Afterwards, we can then use our greeter method in our experiments. So resetting the entire thing, you can see it reads data sample as well as greeter. This way you can have a lot of Python code here and import them in the different parts of your Jupyter notebook as well as your different experiments, avoiding redundancy in your projects. Now, once we have your project all set up, and let's say you want to share these projects with other data scientists, you want these to be easily replicated. To do this, we can export our environment using Anaconda by saying conda env export and stream the entire thing or pipe the entire thing into our environment.yml file. Going to the root of my project directory, we'll say conda env export environment.yml. So essentially, this will take your entire devlogs environment or whatever environment you currently are in and create an environment configuration file in the form of a YML file, which will look something like this. As you can see, it contains the name of the environment followed by the channels where it pulled in the libraries being used by environment, as well as the different Python libraries that you currently use for this environment. Now, if you are another data scientist that would like to replicate this project, you can then mimic or create a copy of that environment, or rather update your current environment using the environment.yml file found in the project by issuing the command conda env update -- file environment.yml -- prove. Or you can create an entirely different environment using conda env create-f environment.yml. So this video, in summary, what we've just seen is how to set up a basic data science project without any third-party libraries by structuring it in terms of directories, having a directory where you can dump your Python files in, having a directory where you can dump your data in, as well as having a directory where you can store your notebooks in. With this setup, your experiments can be easily replicated by other people, other developers, and other data scientists, and you can avoid redundancies in your Jupyter notebooks by referring the different Python files that you have inside your SRC directory. Okay, so that's it for this video.